would have been good one for
On the
me.
interstate.
Alright.
Everyone drives fast on the interstate.
There you go. Okay, so K fast.
Like 100 miles an hour.
Okay, whatever. Instantaneous measure of your speed, right? Correct?
Yeah.
So the reason they can give you a ticket for this without the radar gun on you is because of the mean value theorem. Okay? Basically what it says miles an hour. Okay, so this is what the mean value theorem says. At some point, these two have to be equal if it's a continuous function and differentiable function. Okay. So if you're going 80 over the average, they can say at some point you went 80 instantaneously, which is like them clocking you with a radar, and they can give you a ticket for that. Okay. So average rate of change over an interval equals at some point you were going 80. Okay, so that's the mean value theorem in a real world example. Okay, now we like to get a little bit more mathematical here. Keep it simples for stupids. Yeah. Oh yeah. Okay. That's a closed interval, right? From A to B. Okay, and it has to be differentiable on, okay, now we're not going to worry so much about closed versus open because we don't worry about it much on the AP exam, but just know that's what the theorem says and there's a reason for it. Okay. Then there exists, oh, sorry, that should say at least. It should say at least. Yep. One value, C, AB, where fall asleep on me now. If I'm dumping him into you, I didn't have to. Why did it frighten you?
You need to calm, yeah.
I'm pretty sure. Okay. Okay, there exists at least one value such that the derivative, okay, what's the derivative? This is C, the derivative is the slope of the tangent line, right? Okay, so the slope of the tangent line, the instantaneous rate of change equals the sum average rate of change. Okay. I'll show. So this is the slope of the tangent line, right? Instantaneous rate of change. So right there equals the average rate of change over this interval. So the derivative equals the average rate of change.
Like they're the same.
Yeah, so if this is A and this is B, you can calculate the average rate of change, which is the slope of that line, right? There, it says there's some point where the tangent line has the same slope.
Oh.
Okay, that's all this theorem says. Okay. And the cops love it. Okay. So this is a formal theorem. You have not been exposed to these very much. Okay. It's a black tie affair. Okay. This is what we would call these are the conditions. Okay. So I want to kind of get your brains ready for some theorems. You have several this year that are pretty big. Okay, these are the conditions. This has to happen before. If this happens, then this happens. Okay, so conditions, this is the conclusion. Okay, so if these are satisfied, we can say this is it. It happens. But if, let's say the function's continuous, but is not differentiable, can somebody give me a function that has that property? Yeah, absolute value as a corner, right? Continuous, not differentiable. We can't say this works. Okay? So the mean value theorem does not apply to absolute value functions because they are not differentiable at certain points. Unless that point is outside the interval. Okay? So let me show you an example of how this would be used in calculus. So let's look at, you might see that function, the square root of x, is your interval, and that's all you're given.
That looks like it says nut.
Yeah.
I make my use value like crap. Very nice. Shut up. I can make math jokes, right?
No.
Sure you can.
Even if they're lame.
We're already in the
Definitely do it, though.
Okay, so there's our function. Mean value theorem. This is the slope over the course of the interval, right? And we need it to equal the derivative. So this is step one. Okay, so first, we need to find the average rate of change, or the slope of the secant line. Okay, I say these again and again and again so you get them in your heads. Okay, the secant line has 2 points, and you calculate a slope, whereas a tangent line is 1 point. Right? I think we've been through that.
Probably.
So here, so we need f of 9 minus f of 1, 9 minus 1. This is slope calculation. Okay. Anybody not know where I got those numbers? Okay, 9. F of 9 is square root of 9. F of 1 is square root of 1. 9 minus 1. Right? Square root of 9 is 3. Minus 1 is 2. 8. 1/4. Right? Okay, so that is your average rate of change, or slope of a secant line. Take your pick. This is the number we need. Okay, we want the slope of the tangent line to be the same as the slope of that secant line, right? So tangent line requires a derivative. And then we're going to set the derivative equal to 1/4. Okay, so what is the derivative? Here. Yep. Okay, so rewrite it in power form. So 1/2 x to the negative 1/2. It's a power rule.
Wait, how did you get x to 1/2?
Because it's square root.
Oh, duh.
Yeah. You just give us more and more reasons.
I know.
I like to rewrite it. Okay. So if we want the average rate of change equal to the instantaneous rate of change, set them equal to each other. So 1/4 equals 1 over 2 root x. And solve for x. This is going to give us the x value where that happens. C? Oh, Yeah, when you're looking at the theorem, it says some value C. That's what we're finding. Right now, we don't know what that is. It's any x value. So when you get the answer, it will be that C value the theorem references. But it can still say x equals. Does that make sense? Okay.
Did you put it in 1 over 2 root x just to make it like easier to look into it?
Oh, yeah. I always rewrite my derivatives that way. It's personal habit. Root x equals 2. How about that? Okay. Thanks for the correction. Okay, so if you're a step-by-step person, 1, 2, 3. Okay. If you're a step-by-stepper. Okay. Okay, are you okay with that? You're finding a slope and you're setting the derivative equal to it. We usually set the derivative equal to 0. That's what you're used to, right? Now you're just putting a number in there. It's not a whole lot different than what you've been doing. It's just framed inside of a big mean value theorem. Get it? Okay. Here's how you might see one asked on an AP exam or on a test you might get. You kind of got to think through these because a lot of times they'll throw an intermediate value theorem with the mean value theorem with an extreme value theorem. Yeah, so you kind of got to be able to sort through them all. Okay, so let's. This is straight out of your book, AP problems. Okay, F is continuous. Okay, are we starting to satisfy the mean value theorem?
Yes.
See? It's like word for word. And that's the way math usually works, so it's kind of nice that way. F of 2 is -4. F of 5 is 14. Okay, which of the following statements is... No. Let me rewrite that. The following statements. F2 is -4. F of 5 is 14. Okay. Okay, there's one option. There's another option. Okay. All right. Half the battle's writing these down.
No, I'm not.
Okay. So,
Yeah,
can anybody tell me what theorem this is? The first one. Say it louder. And this is an intermediate value theorem. Because it's a value that's intermediate or in between these two. Right? It's an intermediate value. Now, what theorem is this? What's it called? Yeah, this is a mean value theorem. Okay. Anybody? It's double prime, yeah.
Oh,
Okay.
that's an intermediate mean value.
The intermediate mean? The mean intermediate? No.
Yeah.
Okay, we don't have anything for that. So, what does the intermediate value theorem say? F is continuous, okay, which it is, right? Does it pass 6? From -4 to 14, do we go past 6? So the intermediate value theorem says this is true. Okay, because it's continuous and we pass through 6 here, we know there's some value between 2 and 5. Okay, so this is true. Check. IVT. Do you need me to write the work?
No.
Here's how I think of it. There's 2 -4 and then 514. And we're at 6. If f is continuous, do I have to pass through that 0.6? Okay. Do I even need the x value in this problem? No, I don't. But I know that's true. Okay. So that's true. Okay, what about this one? The derivative is 6. If it's a mean value theorem, what do I need to do with these? What? Yeah, we need the slope here. So yep. So the slope of the secant line is the slope of the tangent line, right? Check. Ooh. Mean value theorem. Okay. Yeah. So this is one of those ones where it would be A, 1 only, B, 2 only, C, 1 and 2 only. You know, it'd be one of those problems, okay? Is there any way for us to check number 3 right now?
I don't think
We haven't applied the second derivative at all yet, so. But there is no theorem for that one, so. Yeah, there's no way to figure that out, so. Okay. We can't do the average rate of change or the average rate of change. The acceleration. Right.
The answer is 1.
The answer?
Uh-oh.
Shouldn't be. According to.
According to
Yep.
Number 19, AP4.
Did you write that wrong?
No? It's D?
Yeah.
Huh, interesting. AP 4, number 19. For that, note to self, don't listen to Hatcher. Okay, so this is how you might see it.
Don't worry.
Okay, no, he's not. He's just off sometimes. Any questions? Okay, for your book work, most of what you're going to see is this kind of stuff, but you're going to get loads of this, loads of it. Okay. Tomorrow is increasing, decreasing, mix, min and max, which I've already showed you. The mean value theorem? It's a good question. If I were writing this book, I would have separated them. So, okay, let me get your work for you. And
I love that. I love that.
It looks like Elvis. Yeah, you did. My life.
clicker.
December 17th.
Because I thought it was like a shadow.
Okay, there it is. Can you read it? 2.5. Let's try 16. Whoops.
I can see it now.
Okay, there you go. So this, now look at AP2, there's a free response in there. Okay, I tell you, put a clock on yourself at 15 minutes. If you need more time and you can do it, please finish it. But if you're stuck, call it a day at 15 minutes, okay? And we'll go over all those in class. We talk about them and talk about them. This is where you start to see more free responses and you get a lot better at them the next 3 weeks. Okay. And then we've started doing AP3s as well, multiple choice. So every day you're seeing AP style problems now. Free responses, multiple choices. You see how you're going to get better? Okay, the silence is deafening.